So as you know, we are studying the chapter based on haloalkanes and haloarenes, and our next topic we'll be talking about the chemical properties of haloalkanes. We have to speak about the chemical properties of both the classes, haloalkanes and haloarenes, but we'll take care of them separately. The first thing, we'll talk about the chemical properties of haloalkanes. Now, chemical properties से मतलब क्या है? What kind of chemical reactions do these compounds show, right? Depending on the chemical structure, depending on the nature of the bonds in these compounds, we can see that what kind of chemical reactions they show. Speaking about haloalkanes, these haloalkanes mainly show three types of reactions, right? The first type of reactions which they show, they're called as nucleophilic substitution reactions, right? You have done all of these types of reactions. ये type सारे क्या होते हैं? You studied them in class 11th. But again, a quick revision based on the name. Nucleophilic substitution. First, it's a substitution reaction. You're replacing something by something else. You're replacing A by B. You're not just removing A, but you're substituting it by B. And what is that A and B? It's a nucleophile, a reagent which is electron rich, which is nucleus loving because it is a nucleophile. It's a electron rich reagent. It has either negative charge or a lone pair of electrons. That is why it is a nucleophile, right? Number second, they show elimination reactions. I'm sure you have read about elimination reactions also in your class 11th. Reactions in which atoms or groups of atoms are removed from the compound. Nothing is added. So they generally lead to the formation of multiple bonds. Valency satisfy करने के लिए जब आप कुछ remove करोगे, then in order to satisfy the valency, a multiple bond is formed. And the third type of reactions which these haloalkanes show, they show reactions with metals, right? These are the three main kinds of reactions shown by haloalkanes. आपके syllabus में सिर्फ nucleophilic substitution है. In detail, we'll be studying only the first type, which is, we'll be talking about the nucleophilic substitution reactions of haloalkanes, right? Let's first try to understand why do haloalkanes show nucleophilic substitution reactions. In one of the previous previous lectures, I already told you that if we speak of the CX bond, this X can be fluoro, chloro, bromo, iodo. If we speak of this CX bond, this is delta negative, this is delta positive because X is more electronegative than carbon. That is why the bond is polar. Since the bond is polar, one of the sides of the bond is electron deficient. It has a slight positive charge. That is why this part of the bond, this part of the molecule, it is always susceptible to attack by a nucleophile. This is how we represent a nucleophile, which is electron rich. Since it is electron rich, it will always attack at the site which is electron deficient. Thus the name nucleophile. Word nucleo is representative of positive charge. Lover of the positive charge, lover of the positive site. It attacks here, and the reason why haloalkanes undergo these reactions is that they have this electron deficient site. So that if we have to show a general reaction, if this is our haloalkane, Rx, it is reacted with a nucleophile. We use a reagent which contains a nucleophile. In this case, this is delta positive, this is delta negative. This will attack the positive site, and what we get is RNU plus X negative. As you can see, X leaves along with the electron pair. Because X is more electronegative, ये जो shared pair of electrons है, it will be more towards X, and when it will leave with that electron pair. That is why what we are left with is X negative. This is the whole reaction of the nucleophilic substitution. What is the substitution taking place here? X is substituted by this incoming nucleophile. But this incoming nucleophile will always have to be a stronger nucleophile than X. It is the simple principle of the universe, survival of the fittest. X cannot be substituted, replaced by just any nucleophile. It will be substituted, it will be replaced only by a stronger nucleophile, a nucleophile which is stronger than X. And this X which leaves from the compound is known as the leaving group. Thus, knowing this kind of a reaction taking place, which is known as a nucleophilic substitution reaction, if you have to define these reactions, how will you define them? The reactions in which a stronger nucleophile replaces a weaker nucleophile. They're called as nucleophilic substitution reactions. This is called as the leaving group, and this is called as the incoming group, the incoming nucleophile. Now, before we do the examples which nucleophiles can replace X, it is very important to remember that आपने जब RX bond की strength पढ़ी, if we speak about its strength, I told you that order of strength, remember, RF is stronger than RCl, which is stronger than RBr, which is stronger than RI, right? Because iodine का size सबसे बड़ा होता है. This is the weakest bond. This is the longest bond, thus the weakest bond. Therefore, this bond is the weakest. On the basis of this, अगर हमें order of reactivity अब define करना होगा इसमें, then order of reactivity किसका होगा ज़्यादा reactivity? The one which has the weakest bond. Then in that case, the order of reactivity towards nucleophilic substitution is this. Iodoalkanes are more reactive than iodobromaines, whatever I said. Iodoalkanes, bromoalkanes, and after that will be chloroalkanes, and last will be fluoroalkanes. So this is the weakest bond. These iodoalkanes are the most reactive, most susceptible to nucleophilic substitution reactions, right? We'll continue in the next presentation.